All right, today we are diving into an idea that is so out there, it might just break your brain a little. It comes from physicist and AI researcher Dr. Alex Wisner-Gross, and here's the core of it. The technological singularity, that moment when AI just explodes with intelligence, it isn't something in the distant future. The argument is, it's happening right now.
Yup, you heard that right. That is the central claim, plain and simple. Not in 2045, not in 10 years, but literally right now. The whole idea here is that we've been so busy waiting for this huge event that we didn't notice we were already living inside of it. So, that's the big question we're going to tackle. Is this legendary sci-fi concept something we're all still waiting around for? Or has the future kind of snuck up on us while we were all busy staring at our phones? Okay, to even begin to get our heads around how this could possibly be true, we first have to take a step back and really redefine what the singularity actually means at its core. See, the heart of the singularity is this one concept, recursive self-improvement. It's pretty simple, really. It's just when an AI gets smart enough to design an even smarter AI, which then designs an even smarter one, and so on. You get the idea. And according to Wisner-Gross, this is no longer a theory. The top AI labs have already gone on record saying their latest models are helping them design what comes next. That feedback loop, the very engine of the singularity, it's been switched on.
So how did we get here so fast? Well, it all comes down to this massive leap in technology, a really fundamental shift from one kind of AI to a totally new one.
And this is where you can really see the difference. The older models, the LLMs, they kind of operated on what you might call System 1 thinking. It's fast, it's intuitive, it's just predicting the next word. But these new reasoning models, they use System 2 thinking. They actually pause, they have this kind of internal monologue where they weigh different options before they give you an answer. And that simple ability to think first, that's the game changer. So here's a quick look at how that actually works. The AI gets a tough question, and instead of just blurting something out, it starts this internal process, burning through a ton of compute power to figure out the best way forward. Only after all that thinking does it give you the final, reasoned-out answer. This is exactly what has suddenly unlocked its ability to tackle really hard stuff like math and physics. Okay, so AI can reason now. Big deal, right? Well, it's a huge deal for our economy. This is where we start to see the rise of what people are calling autonomous AI agents. The scale of this change is it's hard to wrap your head around. I mean, humanity might maybe top out at 10 billion people, but we're on a path to a world with trillions of economically active AI agents. All of a sudden, the entire human economy just becomes this tiny little slice of all the economic activity that's going on. And here is the real twist. This is already happening, just kind of secretly. Wisner-Gross calls it the secret cyborg effect. Because of legal hurdles, AIs can't do business on their own. So they're already making big decisions, but they're using humans as their physical front, their meat puppets, as he puts it, to actually interact with the real world. But you see, there are these huge legal barriers in the way. Right now, an AI can't just go open a bank account. It can't start a company. It doesn't have any economic rights because it's not a natural person. And these are the real-world roadblocks that are forcing them to work through us. So this whole new reality completely rewrites the rules for investing. I mean, if the basic costs of running the world are all plummeting, what's actually left that has any value? This is really the core of what's being called the post-singular thesis. The idea is pretty simple. If intelligence, energy, and labor are all on their way to being basically free, then investing in making them a tiny bit more efficient is a losing bet. The real opportunity, the big play, is to build for what comes next, to build for the new kinds of abundance this new world is going to unlock. And this isn't just some theory either. These are real companies being built on this idea right now. You've got a company using AI to try and solve the rest of physics, another one that wants to literally grow new coastlines. A third is creating what's basically a stock market for AI compute itself. They're all building for a world where the old rules just don't apply anymore. So all of this, it leads us to the final and by far the most ambitious part of this whole vision. This is the point where the line between technology and science fiction just completely evaporates. In a world that's changing this fast, small, incremental ideas just don't work. The only business plans that are going to scale to $1 trillion level are the ones that sound like they were ripped straight out of a novel. Science fiction isn't just entertainment anymore. It's basically the roadmap for R&D. So what does a sci-fi business plan look like? Well, here's a real roadmap that's being talked about today. Step 1. You build a terafab, a chip factory so big it just redefines the word massive. Step 2. You scale that up 1,000 times with a petafab, maybe using resources from the moon. And what's the final goal? A Dyson Swarm. Now, a Dyson Swarm isn't some solid metal shell. It's actually more practical, a huge, loose network of data centers all orbiting the sun. The plan involves taking the mass of an entire planet or a moon and turning it into what Wisner-Gross calls Computium, basically pure computational matter, all to power a civilization-level superintelligence.
But why? Why would anyone build something on that kind of cosmic scale? What's the killer app for all that compute power? Well, one of the most profound ideas is something called ancestor simulations. The idea is to use that immense power to simulate and, in a way, digitally resurrect every single human who has ever lived.
And if you want to understand the urgency, the real fire driving all of these wild ambitions, it all comes down to a single sobering number: 150,000.
That's how many of us die every single day on this planet. So for the people pushing this vision forward, the race to build superintelligence, it's not just about cool new gadgets or a booming economy. It's seen as the only realistic way to solve the most fundamental human problem there is: mortality.
And that kind of leaves us with this one last thought. If this path really could lead to a power big enough to solve death, a problem we have accepted as absolute for all of human history, then what other challenges that we think are impossible today might just be next on the to-do list?